Welcome to Hired in AT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A hiring manager just asked an AI to screen 500 resumes. It rejected the one candidate with exactly the right experience, 10 years in the role, certifications to match, because the AI made a snap call with zero reasoning. That's not a bug. That's what happens when models aren't forced to show their work. Enter chain of thought prompting, the technique that makes AI break down every decision step by step, catching these costly blunders before they happen. By the end of this video, you'll know exactly what chain of thought prompting is and why it's a career accelerator for AI engineers. You'll be able to use zero-shot and few-shot CoT on real problems. And you'll have a whole playbook of advanced reasoning techniques that build on CoT. So you know which tool to reach for when the job demands more than a simple answer. Imagine a medical AI assistant given a patient's symptoms: a persistent cough, mild fever, and fatigue. Without reasoning, it jumps to bacterial bronchitis and prescribes antibiotics, completely ignoring clear indications of a viral infection that wouldn't respond to antibiotics. Now rewind and add a chain of thought prompt. The AI lists the symptoms, checks them against common viral versus bacterial indicators, notes the absence of high fever and green mucus, and rules out bacterial causes. Final diagnosis: likely viral, rest, and fluids. That's the difference between guessing and reasoning. Chain of thought prompting, CoT for short, is a technique where you tell a language model to generate intermediate reasoning steps before giving the final answer. Think of it like showing your work on a math test. The teacher doesn't just want the number, they want to see how you got there. CoT does the same for AI. The concept was introduced in a 2022 paper by Wei and colleagues, and it works with any existing model, no retraining required. You're just changing how you ask the question. Here's how chain of thought flows. You feed in a complex question. The model doesn't dart straight to an answer. It first identifies what it knows, applies relevant logic or math, computes sub-results, and only then hands over the final answer. And because you can see every step, you can catch a mistake before it cascades. That transparency is CoT's superpower. Let's lock in the core idea. Chain of thought blends two powerful ideas into one technique. Can you name them? The same question, two approaches. On the left, the model goes straight for an answer and lands on 57, which is completely wrong. On the right, we added, let's think step by step, and the model laid out a logical chain. 3 balls, add 3, becomes 6, lose 2 gives 4. The answer is now correct, and you can see why. That's CoT in action. Time to lock that in. What gave CoT the edge? Quick recall. What does the model produce right before the answer? At first glance, adding just 4 words. Let's think step by step. Seems almost too simple to matter. So why does it work? Large language models weren't explicitly programmed to reason the way people are. Instead, during training, they processed billions of examples containing worked math problems, technical tutorials, programming explanations, research papers, and logical arguments. Over time, the model learned that when people solve difficult problems, they usually explain the intermediate steps before giving the final answer. When you add a phrase like, "Let's think step by step," you're activating those learned reasoning patterns. You're encouraging the model to slow down, organize its thoughts, and solve the problem in smaller pieces instead of jumping directly to a conclusion. That's why zero-shot chain of thought often produces dramatically better results on reasoning tasks without any additional training or fine-tuning. You're not teaching the model something new. You're asking it to use a reasoning pattern it has already learned. Here's an important concept that often confuses beginners. The reasoning you see isn't necessarily everything the model is doing internally. What chain of thought gives you is visible reasoning, a step-by-step explanation generated for the user. Modern AI systems may also perform additional internal reasoning that isn't exposed directly. Think of it like a math teacher asking you to show your work. The paper you hand in explains your reasoning, but it doesn't necessarily capture every thought that passed through your mind while solving the problem. For prompt engineers, the important point is this: visible reasoning gives us something we can inspect, review, and improve. That makes debugging AI responses much easier than relying on a final answer alone. Zero-shot chain of thought isn't just for math puzzles. You'll use it daily for real work. Let's think step by step as a prefix turns any LLM into a planning, debugging, and teaching machine. 3 use cases: brainstorming a project plan, debugging code, and explaining complex concepts. For each, here's a one-line prompt you can steal. This works across GPT-4, Claude, and Gemini. The phrase is model agnostic. Zero-shot is the speedboat. Few-shot is the cargo ship. Here's the difference. Few-shot chain of thought means you give the model a handful of worked examples, each showing the exact reasoning pattern and answer format you want. Then you drop in the real question. The model mimics the reasoning structure, not just the answer. It's like showing a new hire 3 perfectly filled out expense reports and saying, "Do mine the same way." In production, where consistency is non-negotiable, few-shot wins every time. The model doesn't guess the format, it follows the blueprint. Let's look at a real few-shot CoT prompt for factoring polynomials. The exemplar shows the model exactly how to break down the problem into steps. When we feed the target equation, the model imitates that reasoning pattern and solves it correctly. You've just seen both methods in action. Can you spot the fundamental difference? Let's cement the difference between speed and control. Both methods rely on large language models. While smaller or older models may not show dramatic improvement, on models like GPT-4 or Claude, you can expect significant reasoning gains. Use zero-shot for quick experiments and general tasks. Switch to few-shot when consistency and format matter. That's your rule of thumb. One of the biggest misconceptions about chain of thought is that reasoning automatically means correctness. It doesn't. Imagine asking an AI to diagnose a medical condition. The model carefully analyzes symptoms, compares possible illnesses, explains every conclusion, and confidently recommends the wrong treatment because one early assumption was incorrect. The reasoning looked impressive. The conclusion was still wrong. Chain of thought improves how the model approaches a problem. It does not verify that every fact inside the reasoning is true. That's why experienced AI engineers never confuse logical reasoning with factual accuracy. Reasoning improves reliability. Verification establishes trust. You need both. CoT gives you the play-by-play. It doesn't promise truth. Here's the mental model you need. Every chain of thought is a hypothesis, not a verdict. A single incorrect premise, like the patient's fever indicates bacterial infection, can cascade into a dangerous conclusion, all while sounding brilliant. The only guardrail is a human who verifies. So treat every CoT output like a junior analyst's report. Smart, helpful, but never blindly trusted. When you get a CoT response, run this 4-point audit before you use it. First, check every factual claim. Second, validate the reasoning logic. Third, ensure the conclusion actually follows from those steps. Fourth, if anything looks suspicious, cross-reference with external sources. For example, an AI reasoned, the user mentioned Monday, so the deadline should be Friday. That skips a real-world calendar check. Maybe the project deadline is actually Thursday. Audit Step 2 would flag that leap. Chain of thought isn't the end of prompt engineering. It's the beginning. Many of today's most powerful AI reasoning techniques build directly on this idea. Tree of Thoughts expands one reasoning path into many competing possibilities. React combines reasoning with actions like searching databases or calling APIs. Self-consistency generates several reasoning chains and chooses the most reliable answer. Reflection allows the model to critique its own reasoning. Critique and revise improves an answer after identifying weaknesses. Debate. Prompting lets multiple AI instances challenge one another before reaching a conclusion. Notice the pattern. Every one of these techniques starts with reasoning. That's why chain of thought is considered one of the foundational building blocks of modern AI engineering. Master this first. Everything else becomes much easier to understand. Quick check. Which technique pulls multiple reasoning chains and picks the majority answer? Quick recall. 6 patterns, but which one actually acts on the world? What if you could pit 2 AIs against each other to get to the truth? Debate prompting does exactly that. One model instance argues for a position, another argues against, and a judge AI weighs both sides and picks the winner. This adversarial pressure forces each model to surface better evidence and challenge weak points. Research shows it improves factual accuracy and reduces hallucination on complex questions. Think of it as a courtroom for AI reasoning. The best argument wins. Which technique fits a planning problem with many possible moves? The answer is Tree of Thought. It explores branches, not just one chain. You're not just writing clever prompts. You're building reasoning systems. Job postings requiring AI skills have grown over 70% year over year. Companies are scrambling for engineers who understand a chain of thought, tree of thought, React, and self-consistency, not just basic prompt tweakers. These reasoning patterns are the new literacy for AI engineers, and they directly translate into higher offers. Let's zoom out and look at the bigger picture. In an enterprise AI application, the user submits a request. The prompt is sent to a language model. For simple questions, the model may answer immediately. For more complex problems, chain of thought guides the reasoning process before a response is generated. That response may then be validated against business rules, reviewed by another AI system, or combined with information from enterprise databases before reaching the user. Chain of thought isn't an isolated prompt trick. It's often one stage inside a much larger AI workflow. Understanding where it fits helps you design more reliable enterprise AI systems instead of focusing only on individual prompts. But here's a trap beginners fall into: using chain of thought on questions that don't need reasoning. If you ask, "What is the capital of France?" Without CoT, you spend about 20 tokens and get Paris. Add, let's think step by step, and the model might produce a 150-token reasoning chain. It'll say something like, France is a country in Europe. Its historical capital has been Paris since the Middle Ages, therefore the answer is Paris. That's wasted compute and money, and sometimes the reasoning is hallucinated nonsense. Save CoT for multi-step problems, math, logic, planning. If it's a fact lookup, just ask directly. The cost difference really adds up at scale. From zero-shot to few-shot, here's your CoT cheat sheet. Zero-shot is literally one sentence. Let's think step by step. Few-shot means you give 2 to 3 worked examples that show the reasoning chain. Use these techniques for math problems, logical deduction, and multi-step instructions. Skip them for simple fact retrieval. It's like asking a calculator to show its work for adding 2 plus 2. This cheat sheet covers 90% of what you'll ever need. Let's finish with the 3 ideas every prompt engineer should remember. First, chain of thought encourages the model to solve complex problems step by step instead of jumping directly to an answer. Second, reasoning is not the same as correctness. Always verify important facts, especially when the results affect business decisions, security, healthcare, finance, or legal work. Third, chain of thought is the foundation for many advanced AI reasoning techniques you'll learn next, including tree of thoughts, react, self-consistency, reflection, and AI agents. Master this one technique first. Everything else builds on it. And that's exactly where we're heading next. Chain of thought is linear, one step after another. That's perfect for arithmetic or logical deduction, but it breaks down when a problem has multiple possible paths. Say you're planning a multi-city trip and need the optimal route. A single CoT chain might give you a reasonable path, but it can't compare all alternatives. Tree of thought explores several branches simultaneously, evaluates each, and picks the best one. So here's the rule. If your problem needs exploration of alternatives, scheduling, strategy, creative planning, reach for tree of thought. If it's a clear, step-by-step progression, stick with CoT. Hit subscribe so you don't miss our deep dive into tree of thought, where we code it from scratch. Knowledge doesn't stick until you use it. Right now, open your favorite LLM. Find the practice problem in the description and try a chain of thought prompt yourself. Zero-shot or few-shot, your choice. When you're done, drop your prompt and the model's response in the comments. I'll be in there giving feedback. Like this video and subscribe so you don't miss the next part on Tree of Thought. Now go build something that actually reasons. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.